priority queues. See, when we are in a normal queue, this part is your front and this is your rear end. Meaning you are inserting from here and you are deleting from here. Okay, but some cases, no, again, this is a silly example. When you are standing on a queue line, maybe at some point, okay, when you are standing at a queue line or in traffic road, when some no VIP person is coming on traffic, okay, this is a road, right? Or some ambulance is also coming, or some VIP person is coming, right? Which has more priority vehicle, right? Ambulance is the highest priority vehicle, or some VIP, some minister is going that way. What they do, they will traffic was flowing, they will stop it there to some side, and they'll create a path. They'll give priority to the main important vehicle, right? So that's what meaning, that vehicle is having some priority. In the same line I am going, in the same line I want to go. This is a line I am going here in this road, but when some priority vehicle is coming, you are being by the traffic police, you are made being pushed aside, and this comes first, and that goes out first. Okay, so in normal queue, you do not have any logic. Whichever element is coming, you are inserting there at the end, and you are deleting it from the front. It follows first in, first out. Whichever comes first is deleted first or sent out first. Okay, but that logic is not applicable in priority queues. In priority queue, every element which is being inserted along with the number, it will have some priority. Meaning, let's see the example here. This is a queue. I am having 4 elements. Element 2, comma, a priority, let's take priority 1. Then there is an element 3 with priority 4. Then there is an element 4 with priority 3. Okay, this is the actual element. This is the actual element to be inserted. Along with the element, there is a priority attached with the element. Okay, a kind of key pair values. Along with the element, there is a priority attached. So, first initially what will happen? 2, first this element comes, 2 with priority 1 comes. So, that is the only element in the queue, 2 is inserted here. Then came an element 3 with priority 4. Here assume priority, meaning 4 is the highest priority. 4 is the highest priority. Now, when 3 came with highest priority, you have to remove this 2, put 3 and then put 2. Why? Its priority is 4 and its priority is 1. So, I have changed the order now based on the priority. Next, the element came, 4, element 4 came. Okay, 4 has arrived here. What is the priority? 3. What is the priority of this 2? 1. It means I have to remove this also, put this 4 with priority 3 and that insert 1 with priority 1. This way, you will be changing the order. Okay, priority queues, you will be changing the order. Whichever is having more priority will be inserted first. Again, that is user defined. You may define one means first rank. So, 1 rank fellow should be given first priority. That is our choice. Whether you decide 4 as the highest priority, 4 or any number. Since I have taken small numbers here, 4 or any number. Okay, highest number is having highest priority, that can be your definition, or lowest number, that is ranking, is the highest priority, that can be our choice, that we can define while writing the when you are implementing the priority queues. Okay, so it, like in normal queue we follow first in first out, whereas in priority queue we change the order according to the priority of that particular element which is being inserted, right? Where do we use this? It has lot of applications. One, in your operating system, right? So there are so many processes, P1, P2 and so on, Pn processes are there, right? So when there are processes here, some P1 is running, P2 is waiting in queue. Okay, your CPU is executing maybe process P0, it is executing that, but suddenly a high priority came, a high priority process came, P3, which is very important, I have to execute this. What generally in operating system, what is happening? This P0 is kept in the waiting queue, P0 is kept in the waiting queue, and this P3 is processed first. Then after this is done, the pending part of P0 is executed, right? That way it has lot of applications about this priority queues. Let's try to understand what is theoretically, what is priority queues. Okay, point is very simple. When you're inserting an element, it comes with some priority. Okay, it has some priority along with the number. So priority queue is a type of queue that arranges the elements based on their priority values. Okay, elements with higher priority values are typically retrieved or removed first before the elements with the lower priority. Right, each element has a priority value associated with it. Every element which is being inserted into the queue will have a priority element. Okay, priority value will be there. When we add an item, it is inserted in a position based on its priority value. This example which you remember, already we had 2 and 1, then 3 and 4, then 4 and with priority 3. So first this was there, element 2 was there here. Then 3 came, so I removed this 3. I removed this 2, I kept 3 here and then 2. Then 3 came, element 4 came with priority 3. So again I removed this and kept 2 here like this. Okay, that's what it is stating. Element that has, when we add an item, it is inserted in a position based on its priority value. Okay, priority queues are often used in real-time systems, right? Where it is used in Dijkstra algorithm, in Prim's algorithm, Kruskal's algorithm, Huffman coding. A lot of problems will be using this priority queues concept. Okay, so when we study graph theory, trees and graphs, we'll be seeing what are these algorithms. That's what I said. Priority queues is mostly used in trees and heap data structures and graphs also. So we will see its application in these algorithms when we study them in the next course. What are the properties of priority queue? Priority queue is an extension of the queue with the following properties. Every item has a priority. Okay, element with highest priority is dequeued before with the lower priority. If two elements are having same priority, already if there are two elements, they are served according to their order in the queue. Okay, if two elements are having same priority, in whichever order they are appearing in the queue, the same order will be maintained. Operations we do, insert, delete and get minimum, get max. Again, these things you will understand better. So inserting means you are inserting key as well as the data. Okay, insert data with the key to the priority queue. So elements are ordered based on the key. Key is your priority ranking that you define it. When you write the logic, you write it accordingly. If you define 1 as the highest priority, you can write a logic. If you define some 10 as the highest priority, you can define accordingly, right? Then delete, min, delete, max, remove and return the element with the smallest, largest key. Okay, in queue we can delete the minimum, means again that's what minimum or maximum. If you want to delete the highest priority one or you want to delete the least priority one, you can do that. Same way you can print the value of least priority and highest priority, right? How is the priority assigned to the elements in the priority queue? In what way are we assigning the priority to the elements in the priority queue? Generally, the value of an element is considered for assigning the priority. This is a simplest case again, meaning suppose I want to see an example here. I have a string with me, HELLO. This is a string. Okay, here there is no priority given to me. Assume only a string is given to me. Again, some characters are given to me. HELLO characters are given to me. I want to insert them in a priority queue or normal queue, but I want to follow some priority. What is the priority which you can follow? Whichever element's ASCII value is high, that you assume as high priority. Whichever element's ASCII value is high, that you assume as high priority. Initially H will come, okay. Then E will come. Again, E is lesser than H, okay. L came here. L is having higher priority than E and H both. So E and H will be removed. And L comes here. Okay. Then comes your H and E. Right. Again, next one more L is there. So here if you see E, then H, then L, both are having same priority. So this L remains there only. The second L comes here. Then comes your H and this. Next came O. O is having the highest priority among everything. So the O is inserted at the front. So like this it is inserted. So always it need not be a key. A priority is not required. Without having a priority element, still you can follow the logic of priority. How this is the case? Or if the elements are coming, like some 3, 5, 2, 1, 4. Okay, only these are the elements I want to insert. And the priority defined by us is highest number is having highest priority. That is the rule. So there is no associated priority here. From the elements itself, we are defining a priority. Okay, so how am I defining the priority? I am saying the highest element is the element with highest priority. So this is having first rank, this is having second, this is having the third rank, this is having the fourth rank, and this is having the fifth rank. That way you can insert the elements. Indirectly there is a priority in those elements. Okay, that's what is being discussed. That's how priority is being assigned to the elements. Or else you can have key pair elements. You can have the element as well as the priority. For this you can use some structure. You can define a structure, or in linked list also you can have those two element here and the priority and the next element address. Like this you can implement it, element and priority, next element address. Okay, so we can use different implementations for that, but priority need not be a special number. It can also be retrieved from the elements which I am inserting. There only you can define a logic. You can assume. That's what. See, priority can be assigned according to our needs. Sometimes lowest value can be assigned highest priority. Sometimes highest value can be assigned highest priority. Okay, it's our choice, right? How do we implement? What are the different ways of implementing priority queue? One is array, then is linked list, then is heap data structure, and binary search tree, right? So these two are the very important implementations. Priority key is widely used in these two data structures, heap and binary. There are so many problems in this without which we cannot do. We need definitely priority queue in solving problems of binary search tree and heap data structure. Okay, and as usual, arrays and linked list, like you are implementing your normal queue, you're using circular array, concept, or you're using linked list concept to implement this priority queue, right? So since these two are new for us, this we will skip this for now, because these two we'll see in unit 5 when we study the data structures, tree and heap structures. Okay, but array and linked list are easy. How do you do the array implementation of priority queue, right? So you need two things here. You need to store element as well as the priority. Your structure should contain the element which you want to insert and the priority. And you can create an array variable for this. You can create an array variable a of q. You can give some q of some 10. Like this, you can create 10 elements. It means you have q of i dot item will be there, element key of I dot priority will be there. For every element you will have an element as well as the priority. For a structure, you are creating a structure with two elements, right? Item and priority. So like this you can keep doing those operations. You can compare and you can implement this using arrays. Okay, then using linked list, again it's very simple. In linked list implementation, your node structure will contain three things. In single linked list also, you can create three nodes, like we are doing in double linked list. Actually, in double linked list, you are having two pointers. This is pointer P1, this is pointer P2. This is the integer element, or this is the element which I am inserting. Right here, you can in single linked list, you define your structure like this: struct node. Let there be int item as well as priority, and then struct node star some temp or next. You can give it like this. So in single linked list you have three elements. This is the element, this is the priority, this is address of next element. Okay, this way you can implement the priority queue. So I can have another node, I can create element, the priority, and the next address. Element, priority, and this is null. So this is your head. So when you are inserting, you will be checking its priority and decide whether I have to insert it before this or at the end. Okay, in both the ways you can do this. right? So these two implementations exist. For now, we are studying array implementation and linked list implementation. Okay, so priority queue is all about, along with the element, we are having some priority defined. I can define the priority with an additional variable, additional number, or inbuilt in the elements itself. I can define some priority. Maybe ASCII value, maybe highest element is having highest priority. That way we can perform this. It has lot of applications in tree and heap data structures. We'll be studying it there.